Okay, again, we're going to look at constant proportionality. We're just going to keep practicing this. I want to make sure that giving you enough different contexts so that it is clear in your mind what the constant proportionality is and how to determine if something is proportional. Okay, in the first worksheet, the front side of the worksheet in the packet, it says make a table for each line. So they're giving you the graph. And again, we're taking the graph and we're saying, what does that tell us? What information can we use to put into a into a table? And then they're saying which has the greatest constant of proportionality. And I'm going to make a significant point here in this. There is an additional piece that I want you to notice. So these two pieces, these two on the front and back of this sheet, has a new piece that I'm adding in. So here's what we got. We have A and B, and I can see that when A is 1, in line A, when X is 1, then Y is 3. So if I have 1, 3, that means 2 is going to be 6, 4 is going to be 12, and 6 is going to be 18. And the constant of proportionality is 3. I'm multiplying by 3 each time. In B, I'm looking for, I look at 1, but I notice that 2 is on a vertex. And when I'm looking for a point, I really want to look for a vertex because I can assume that 1 is a half on the y, but if I have a point on the vertex, I can really, I know for sure that that's it. So I'm looking at this, and I can see that when x is 2, y is 1. So I can see that when x is 4, y is 2. When x is 6, y is 3. So I'm looking at where there are vertex points, and I can see that those are exact, and I can put that into my table. So I know that every time I have x, I'm going to multiply by 1/2 to get the y. And so the constant of proportionality is 1/2. Okay, again, we're gonna finish up here on this sheet, and then I'm gonna connect this top piece with the top piece on the problem to the right. Okay, let's look at this bottom piece. We have you want to buy some candy for the birthday party. There are 2 different grocery stores, and you want saltwater taffy. And I had a lot of saltwater taffy in my childhood. I don't know about you guys, but was from the East Coast. So at the shore, at the East Coast shore, when I would go, throughout the summer, they would have a lot of saltwater taffy, especially in Atlantic City and Seaside Heights and all the places I used to go when I was a kid. Okay, so 3 pounds is $4.50 at the first offer place. So the first offer place is, and I can see that if 3 pounds is $4.50, I know that 1 pound is going to be $1.50. Okay, and in the second grocery store, saltwater taffy is $1.75 a pound. Well, they give me what the unit rate is, but that is definitely more than the first offer. And so I can, I take the information out of my table, and the first one's there, and the second one's there. Okay, and the first one is definitely less than the second. All right, I'm going to go over to the top of the back of this page, and we are going to look at using the table and the graph to find out the constant of proportionality. So first thing we need to find out is which of these graphs match which. So I'm looking at A, and in A, and I highlighted the points before I copied this for you, 2 is 6. 2 is 6. So I'm looking, where is 2, 6? Well, 2 is 6 here. So this must be A. Okay. In B, I'm looking at 2, and 2 is 3, right? Up 2 over 3. So here's 2 and 3. So this must be B. And I'm thinking that's C, but let's see. I'm looking, here's a point on the vertex, right? 6 is 2. And yep, there we go. And so I have figured that out. But I added in on the top for you to see if you could figure out what the constant proportionality is. So when I look at x in this in A, 6 times 3 is 6, 3 times 3 is 9, 1 times 3 is 3. So the constant of proportionality is 3. In the second one, I'm looking at the constant of proportionality, and I'm looking for what am I multiplying the x by to get the y? And each time I'm multiplying times 1.5, okay? Because 2 times 1.5 is 3, 4 times 1.5 is 6, so every time I'm multiplying by 1.5. In C, I'm in the one that relates to line C, what am I multiplying x by every time? So if I multiply 3 by what do I get 1? Well, that would be a third. Okay, so I would either say it's 1/3, or I could say it's 0.33 repeating. So either one I could multiply by. Now, this is what I want you to notice. I want you to notice in these 3 graphs. Notice the constant of proportionality. So the constant of proportionality in the first problem, the number where it is 3 is greater than 3 is greater than 1/2. In this case, 1.75 is greater than 1.5, or $1.50. And in the third problem, I have 3 is greater than 1.5 is greater than 0.33 repeating. And if you'll notice, the number that you're multiplying the x by increases or makes that line steeper. So the number you multiply times the x impacts or decides or determines how steep that line will be. And that is a very important algebra piece that we are going to look back at. And so if you're not quite sure, that's okay. We're going to be coming back to this throughout the next several months. But I just want to say this is the first time we're noticing this, where we can notice that the constant of proportionality that is the greatest makes the steepest line. Okay, we're going to move to the last problem here. So the Jones family drives 200 miles in 5 hours. So I want to know what that would be in 1 hour, and I would divide, I want miles per hour. And so then I would take 200 and I would divide it by 5, and I would find out that there are 40 miles per hour. And so 2 times 40 would be 80, 3 times 40 would be 120, 160, and 200. And their unit rate is 40. The unit rate is 40. And because I have 0, 0, it is also the constant of proportionality. The Grant family is 360 miles for 6 hours. So I still want miles per hour. So I'm doing 360 divided by 6 hours. And so that is going to be 60 miles per hour. And I'm going to fill that in. 180, 240, 300, and 0. And so that Grant family unit rate is going to be 60 miles per hour. So which family is driving faster? I can say that the Grant family is driving faster, okay? And I know that because they have the greatest unit rate, okay, or miles per hour. Miles per hour. There we go. Okay, that has a lot of different things in it. It's such a rich activity.